Okay, so you guys can check your answers now and let me know if you need me to go over it, but you have to do slide 6, number 5 and 6. So you didn't have to graph for these because these were just like the basic inequality section. The answer for number 5 is y is greater than or equal to 5, and the answer for number 6 is x is greater than or equal to negative 7/6. Does anyone need me to go over that? Okay. Next, again, we only had 4 problems, so they should be quick. Slide 25, number 3 and 4. This should have been your graph and your answer. Does anyone need me to go over this? Okay. So then let's just jump on into our lesson. Okay, so this unit is just the very basics of functions and relations, and I think the next unit or the unit after, we're doing more actual things with functions. So this is just like background knowledge to prepare you guys. So we're going to start with some definitions. I'm going to give you a lot of time, but throughout each section, we're going to be actually applying the vocab words. So don't worry if you don't, like memorize all of them at once. You'll understand once we actually use them. Then we're going to do like what is a relation. Then we're going to find domain and range of numbers. And then we're going to do some functions, graphing functions, and then some more problems. Hopefully we get to that. Again, anything we don't finish is homework. But since we start early, we might have extra time. Okay, so first, most functions are graphed on a coordinate plane, which can be seen here. And it's formed by the intersection of two number lines, the horizontal axis, so this one, and the vertical axis. Hold on, let me. And then the x-axis is the horizontal axis, so this one. And I think it's labeled, but I don't know if you guys can see that. And then the y-axis is the vertical axis, so this one. And together they form the plane. Quadrants are the 4 regions which the x and y-axis separate. So this would be a quadrant, this would be a quadrant, this would be a quadrant, and this would be a quadrant. So they're all named, but they go counterclockwise. So this is 1, and then as you go this way, it increases by 1. And then the origin, let me clear this, is the point at which the x and y axis intersect, which the coordinates are 0, 0, so it's here. And again, this is very basic, so you probably should know this, but if you don't, that's where we're reviewing it. Okay, so next, an ordered pair is a set of numbers or coordinates written in the form x, y. So for the origin, it would be 0, 0, and these are parentheses. X coordinate is the x value of the ordered pair, so it'd be this one. And then it represents how much on horizontally, so left or right, you go. And the y coordinate is the y value over ordered pair, and it represents the vertical placement of the point. So it's just how much up and down you go. Discrete graph, a graph that consists of points that are not connected. So if you had plane here, it's just a graph with a bunch of points like this. And then a continuous graph is one that has a line or smoothed curve, so it's connected. So you could think of it as continuous connected. So sorry, that was bad. So this would be a continuous graph. All these points are connected. Okay, let's move on. A relation is a set of ordered pairs. And we'll get into that next. It's just a multiple ordered pairs. A domain is the set of the first numbers or x values of the ordered pairs in a relation. And this is also known as the input in a function or an independent variable. And the range is the second number, so the y values of the ordered pairs in a relation, and it's also known as the output or the dependent variable. And then mapping just illustrates how each element of the domain is paired with the element of the range. We'll get into this, I think, the section after the next one. And you want to remember when you're doing mappings to order the numbers from least to greatest. Okay, a function is a relation in which each element to the domain for the domain. Oops, I did that. That was a typo. Element of the domain is paired with exactly one element of the range. So for every x value only has one y value, so they can't repeat. A function notation is a way to name a function that is defined by the equation replacing y with fx. So f of x, sorry. So how you say this is f of x, and instead of having it be like y equals 2x plus 1, you put f of x equals 2x plus 1. An input is a value substituted for an x value in a function. So in f of x, this is the input. Again, it's also known as the domain, x, or independent variable. And the output is the result of substituting the value into the function, so the range, y, or dependent variable. So it's either y, or since y equals f of x, or f of x. Vertical line test, and we'll do this in a second, I think. If any vertical line passes through the graph of a relation no more than once, then it is a function. But if you go through, there's a vertical line, and if it was a circle, it would intersect the line in 2 points, and that would mean it's not a function. Zeros are the x-intercepts of a graph of the function. So the point where f of x equals 0. So, or the points where y equals 0. Okay, now we're gonna get into graphing. So, as I said, this is how coordinates are written. It's in the format parentheses x comma y and then close parentheses. X again is how much left or right you go. So this is the x-axis, sorry. Y is how much up or down you go. This is the y-axis. And the origin is where they intersect, which is in the middle. And then some other useful information to know is that when x equals 0, you don't move left or right at all, because when you move, you start in the middle or the origin. So if it's x equals 0, you don't move at all. So the point must be somewhere on the y-axis. And then similarly, when y equals 0, you don't move up or down at all. So the point must be on the x-axis. Okay. And I think I mentioned this, but the order of the quadrants goes counterclockwise. It's just the different sections that the plane divides into. So quadrant 1 would be here, and in this quadrant, x and y are both positive. Because when you move to the right, the numbers are positive. When you move up, the numbers are positive. But in quadrant 2, the x is negative, but the y is positive, because when you're moving to the left, the numbers are negative, and then when you move up, it's positive. Quadrant 3, both y and x are negative, because here you're moving down and then also to the left, and on a number line that's negative. Okay, and lastly we have quadrant 4, and the x is positive and the y is negative, because for the y you have to move down to get here, and then for the x you have to move to the right. Okay. Again, this is very, very simple. So practice problems, since you guys are on paper, it should be easier for you guys. I guess I'll do an example just in case you guys are all from different grades, so I don't know. So for the first one, graph 2, 4. Okay, so 2 is the x value, so that's how much left or right when we're going to move. And when you move right, it's positive. When you move left, it's negative. So 2 is a positive number. So we're going to move 2 to the right. And we end up here. But that's not our final point. We have to move up 4. If the y value was a negative, we would move down. So 2, 1, 2, 3, 4. That's how you graph. And as you can see, number 4 says name the graph's ordered pair. We kind of just did that. It's 2, 4. So why don't you guys graph number 2 and 3, and I'll give you like 1 minute to do that. And then like hold it up to the screen, or you could just check your answers with me. Okay, you guys should be done. So these are the answers. I don't think anyone needs me to go over that, but I'll just show it for a few seconds. Okay. Next, we're gonna go into relations. So a relation is a set of ordered pairs. The set of x values is called the domain, and the y values are the range. So when you're mapping out a relation, you always want to write domain and range from least to greatest, and you don't want to write the same numbers twice. And that'll make sense in a second. So, find the domain and range, and this is a relation. It's just the set of ordered pairs. Again, it's just multiple ordered pairs together. So in order to find, these are all the different ways you can represent a relation. So in order to find the ordered pairs, it's just the numbers. So let me show you. How did I do this? Okay. So yeah, I'll cover this. Again, domain is the x values. So you just basically take all the x values and put them in a list. Again, from least to greatest, and you don't want to repeat any numbers. Okay, and then second, for a table, again, you just put the x and y values and you put them together. But here you have to have them match up. So -3, 1 has to be the pair. So it doesn't really matter if you go from least or greatest. And then when I say mapping, this is what I meant. So, oops. You want to make 2 circles, label them either D for domain or X, and then for the Y, either R for range or Y, and then list them least to greatest, and then you want arrows showing which numbers are pairs. And then lastly, just graph the pairs. Okay. How about you guys do number 2 and then put your answers in the chat, and then for the ones you can't do that, hold up the answer to your screen. Okay, is anyone finished? Okay, I'll show the answers. So most of these are pretty self-explanatory. I think the only thing you should have a problem with, if anything, is the mapping. Does anyone need me to go over that? Okay. Let's move on. Okay, so we're gonna do more with the domain and range. For domain, to find the domain, when you're not given an order pair and you're given a graph, you want to scan your pencil left to right, so horizontally, like that, since domain is X, and identify the X values that are touching the graph. And use X variable when describing domain. For range, scan your pencil top to bottom and identify the Y values that are touching the graph. And then obviously use your Y value variable when describing the range. If the function is just a vertical line, it's undefined, because we'll learn that functions are y over x, and if it's a straight line, it, like, the equation is undefined. Horizontal line means that x equals n, so whatever number that the line is on is n. So if it's a horizontal line on y equals 3, then n equals 3. Arrows indicate that it goes on forever, so all real numbers is a possibility for these. So for example, the first one, for the domain, you want to go left to right. So see where the values stop. So the value seems to stop at 2 comma here, which is 2 comma 3, and over here negative 2 comma 3. So that would be the domain. And then the range, up, you want to scan your pencil or cursor in this case up and down, and it ends at 0 comma 1 and 0 comma 5. So let's, oops. And you want to write these as inequalities, I forgot to mention. So, like I said, it was 2 and negative 2, so x is between these two, and can also be negative 2, and it can also be 2, so it's greater than or less than or equal to, not just greater than or less than. And then range, again, it was 1 and 5, and so there's that inequality. Okay, why don't you guys do number 2 and type in the chat your answers. Okay, so I got one answer, so I'm gonna assume that you guys are all done. For this one, both the domain and range were all real numbers, and the answer I got in the chat was a little different, so let me explain it. For y, let's start with the range. Obviously these arrows are pointing infinitely up and down, so that would make sense. But for domain, I think it's a little less obvious, but if you can see, these arrows are like going, if you kept on drawing them, they would slightly move outwards. And if this were to go on forever, which theoretically it is, it would be all real numbers. It's growing at a lot slower rate than the range, but it still is going to eventually be all real numbers. Okay. Why don't you guys try number 3? And when you guys are done, you can just type the answers in the chat. Okay, so it seems like no one's gotten it, so I'll just go over it. So for number 3, if we look at the domain first, you can see this is moving outwards. So if it's going on infinitely, it's eventually going to reach all real numbers. So for domain, the answer is all real numbers. Okay. But for range, we could see it goes infinitely up. So we know that its top value is infinity, but it still is not going infinitely down. So we can't say all real numbers. It has a limit here on -6. So the final answer would be for domain all real numbers, and then for range y is greater than -6. Okay, I'll leave number 4 for homework. Let's move on. Okay, now we're gonna get into simple functions. Okay. So a function is a special relationship between values. Each input x has exactly one output, but each output or y can have multiple inputs. So for example, here this is a function because every x has only one y, but this is not a function because there are two negative ones that have different y's. So here, one input has two outputs, which is not a function. Vertical line test, I think we went over this in the vocab, but it's if a vertical line intersects a graph more than once, then it is not a function. And this is for when you're given a graph. So, this is not a function because if you put a vertical line, it intersects or at 2 points. Vertical line test, it can only intersect at 1 point. Here, this is a function because it only intersects at this 1 point. Okay. So for these practice problems, you're just determining if they're a function. So, number 1, I'll do with you guys. Here we have, you want to check all the inputs and outputs to make sure each input only has one output. But as you can see here, 5 has -2 and -5. So this is not a function. Why don't you guys try number 2 and 3 on your own and type whether it's a function or not in the chat. Okay, yes, these are both functions. You might see here the outputs have multiple inputs, but that is fine for number 2. And then this, the inputs never repeat, so that is a function. Okay. Yeah, why don't you guys try number 4 and number 5? And this should be quick. Okay, yeah, so number 4 is a function. We're given a graph here, so you can use the vertical line test. At all the points, it only intersects at 1 point. Number 5 is not because it intersects at 2 points. Okay. These are the answers. Okay, we have 2 more topics and we're done, so we might finish early, but don't forget you still have homework. You have at least 4 so far. Okay, equations and graphing of functions. So functions can be represented by an equation or a rule. The equation will generate ordered pairs by taking input that results in a certain output. So f of x or y or the output is the output of an equation. The graph of an equation is the set of all its ordered pairs, which often forms a line or a linear function or a curve, which is nonlinear. Think of a function as a vending machine, where you enter a certain code, which is the input, which produces an output. And each code only gives you one specific item, meaning each input only has one output. So each code can only give you a specific item. You can't use the code for another item. The x value is called the independent variable because you can choose it. Remember, f of x. And the y value is called a dependent variable because its value will depend on the x value. And you'll see this. So function notation, instead of y equals 4x plus 1, again, it's f of x equals 4x, or sorry, minus 1. And as you can see, fx or y depends on what x is, because if you put a 3 in here, the answer is going to be different. There's no y, it's f of x. So again, f of x is the output and x is the input. For example, if you put f of -7 and you replace all the x's in the equation with -7, you get -28 minus 1, which is -29. So again, this depends on like this equation. Okay, let's do some practice problems. Okay, here it doesn't really say it, but here, I'll type it in. Okay. So graph y equals x plus 4 or f of 3 equals x plus 4 and find what f of 3 is. And I'm going to do the same thing. Okay, whatever. So f of x here is being replaced with 3. So we want to replace all the other x's with 3. So x plus 4 will turn into 3 plus 4, which is 7. And if you were to graph it, you'd want it to be y. And oh yeah, I don't think I taught you guys this. Let me teach you guys. So when you have equation in this format, the constant, whether it's -4, +4, whatever, will be your y intercept, sorry, which is where your line intersects with the y-axis. So that's the one going up and down. So 4 is going to be your y-intercept. And again, you can see here 0, 4 is where the line intersects with the y-axis. And whatever number is the coefficient of x here is going to be your slope. So slope is basically just y over x or rise over run. So if in this case the coefficient is 1, so y over x would be 1 over 1. So in order to find points, you go to the y-intercept and you want to go either down, left, right, or up in order for it to equal +1. So for one of the points, you could do up 1, so rise, over run, so right 1, that's +1. +1 divided by +1 is +1. So your next point would be here. That's how you do that. Why don't you guys try number 2 and yeah. You could just hold your page up to the screen. Okay, so are you guys done or do you want me to give you more time? Okay, I'll give you guys like 1 or 2 more minutes. But you should be finishing up. Okay, you guys should be done. So, does anyone want me to go over it? Okay, well, here's the answer. And again, a way to tell if it's a positive or negative slope. Here, the coefficient is negative, and the negative slope, if you're reading from left to right, will go down. And if you're reading from left to right again, a positive slope will go up. Okay, let's do number 3 together. So you want to find the range given that the domain is the set of numbers. So basically what you're going to do is plug in the domain for all of these. So -1 times 3 plus 1 is -3 plus 1, which is -2. So the ordered pair is going to be -1, -2. And if you were to graph that, you would graph it, but I think here I just want you guys to put it in brackets. So next, 0 times 3 is 0, plus 1 is 1, so that's where that 1 came from. 1 times 3 equals 3, plus 1 equals 4. 4 times 3 is 12, plus 1 is 13. That's how I got that. Okay, why don't you guys do number 4? And type in the chat, because this one you don't have to show anything. Okay, so Kyle, you want to find the range for all of these values, not just one of them. Oh, you guys should have gotten this. So you basically just plug in. Oh, wait, now I got it. Kyle, you should be right. Yeah. So you just plug in all these numbers for x, and you should have gotten -7, -6, and -2. Okay. Now we're gonna move on to word problems, and this is our last topic. For homework, you should have like 5 problems. It's not that much. You really should be able to get it done. Okay, the independent variable is a variable that is not impacted or does not depend on another quantity, sorry. And dependent variable is a variable that does depend, so dependent variable, or is influenced by another quantity. So this determines that. This, the independent variable, determines that, or the dependent variable. Again, some more vocab words. Discrete graphs are situations where you logically cannot continue the data. So if I had my graph here, and the x-axis was the number of dogs washed, and the y-axis was the amount of money I made because I'm a dog washer now. And it grows, right? Okay, well, you can't have a continuous graph here, even though I drew it, because you can't, if this was 1 dog, this is 2 dogs, this is 3 dogs, you can't have half of a dog washed. Like, you know what I mean? You can't have 1.5 dogs washed and see how much money you would have made if you washed 1.5 dog, because they wouldn't pay you for that. Like, you can't do that. So for this, you would have a discrete graph. So the points are separated. And that's how you determine if you use a discrete or continuous graph. Sorry. Continuous graphs, again, are where you can smoothly assume partial units. I'm at situations. I'm sorry, there's so many typos on here. So like if it was like the number of gallons I drank compared to how much money the water cost, you can use a continuous graph because you can have part of a gallon. You can have a fraction of a gallon and it will still make sense. So that'd be a continuous graph. Okay. Let's do the first one together, and then you guys do number 2, and then number 3 will be for homework. So anthropologists use the length of certain bones of the human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height of centimeters of a female with a femur, the length of x, the function h of x equals 61.41 plus 2.32x can be used. Find h46. So, again, 46 here is replacing x. So you just want to basically replace the equation, replace all the x's, in the equation with x. So, let me type this out actually. So you would get h of 46 is equal to 61.41 plus 2.32 times 46. Oops. And if you calculated this, I'm not going to calculate it. You're going to get 106.72. So you're going to get 61.41 plus 106.72, which should have gotten you with 168.13 centimeters. You always want to label. So again, this isn't hard. You just substitute and replace things. Because again, the y or f of x depends on the x. Okay. So why don't you guys try number 2 on your own? I'll give you 5 whole minutes, so you guys should get this done. And number 3 will be for homework. And again, once you get the answer, type it in the chat. And make sure to label. So you want to solve and write a formula to represent it. You're not just writing a formula. This might not be clear, but you also want to find the balance. And it should be in the format of f of x equals whatever. And your answer should be labeled with dollars. Okay, so let me go over this. Again, let me get a text box. The total bank loan for Sarah's new car is $15,265. $15,265. The bank automatically withdraws $295.80 each month to pay off the car. Write a formula to represent this sequence to find the balance of the loan after 2 years. So here you have to do some conversion because this is each month and they're asking for 2 years. So you have to convert, well, each year has 12 months. 2 years is 24 months. Okay, so let's do the f of x would be the original car payment on its own is $15,265. So that's standing alone. Everything else, withdrawing $200 or whatever from each month is added on to this. So $295 per month. So if we make x equals the number of months, we can make we could just multiply this by x, and that's how you find how much money she owes. Okay, so if you want to find the loan after 2 years, it would be f of 24, because again, each year has 12 months and the payment is monthly. So you're gonna get 15,265 plus 295.8 times 24. And let me just pull up my calculator. 295.8 times 24 plus 15,265. You should have gone 22,364 in 20 cents. So here's the answer. This is kind of formatted differently, sorry. This is, again, her initial payment. This is how much she's getting monthly, and I put M for months originally. And again, you want to make sure you have that dollar sign. Okay. So again, don't forget you guys have homework. I'll post it within like half an hour. Thank you all for coming, but you are, oh wait, you guys didn't get to even see my screen. I'm so sorry. What I was trying to show is this. But yeah, don't forget you guys do